Algebra 2. We are still in the unit with monomials and polynomials, but we're going to switch to factoring today. And this is an extremely important concept that you need to learn for Algebra 2. It's one of those math concepts that you'll continue to use throughout the rest of your math classes. So factoring quadratic expressions. Quadratic just means that a lot of these problems will have powers of 2. There are 5 methods that we're going to learn, 5 methods of factoring. One is called greatest common factor, or GCF method. The second one is difference of squares, and I just use the first 3 letters, or the first letter of each of the 3 words, DOS for an abbreviation. Third is trinomial method. Fourth is grouping, and then 5 is sum or difference of cubes, SOC or DOC, so sock and dock. Again, you see the 5 methods on the left side in the table, and basically on the right side it shows you like how many terms should be present in the problem. So if it is a GCF problem and you have to recognize what type of factoring method to use, with that one, GCF works for any number of terms. Sometimes you'll have 2-term problems like a binomial. You could have trinomial. You could have 5 terms and all of them still have a greatest common factor. To be a difference of squares problem, there has to be 2 terms in the question. Trinomials, prefix tri, has to have 3 terms. Grouping will have 4 or more. And the sum of cubes, difference of cubes, sock dot questions, they will always have 2. And so the reason I want you to write this down and to keep it in your notebook and continue to look at it until it's in your head is when we get through the entire unit on factoring and we're having to put all the problems together and mix them up, you have to be able to, as quickly as you can, recognize what method is going to be best to use. And so this is kind of going to help that game plan. If you know how many terms are in the problem, then you can kind of put them in a category and then use that method to help you find the answer. We're going to start with the first big method in factoring called greatest common factor, GCF for short. And basically what I need you to do is write down the 4 descriptions you see on the board. It's basically talking you through how to find a GCF. First, you're going to find the largest number that divides into all the numbers you see in your problem. You're going to have to find the largest number that divides nicely into all the numbers that you see. Next, I need you to look for the least number of times each variable appears in the problem. And the reason it's least instead of greatest is because we're trying to find what they have in common. So basically, you're going to look for the smallest power on each variable and the largest number that divides into all the numbers. When you figure out what each of those are, then that's going to be the GCF. And that GCF is going to go outside the parentheses, and you're going to then use distributive property backwards to figure out what terms go on the inside. And so you'll have, like the GCF will be here. Okay, so there'll be some kind of term here, and then you'll have parentheses, and your job is to figure out when you know the GCF, this number or this term times something, and you'll put it here so that when you're using distributive property and you multiply these together, it should give you the same problem back. So all of these questions in the factoring unit, you should be able to check and see if you're on track, and you need to make sure that you practice that because that will make you understand the concept better. Okay, start with some examples. For the first one, we have 15x to the third y to the second minus 45x to the second y to the fifth. I want you to notice that there are two monomials here, separated by a minus sign. Also notice that the powers on x and y are different. So these are not like terms, and you will not obviously be able to subtract them. In order to factor, and when we're factoring in this unit, I'm actually let me connect it back to the last unit. This would be considered the answer in the last unit. And so I'm pretty much giving you the answers as problems, and your job is to work backwards to figure out what the factors are. So let's go through the steps, and then I'll come back to that statement. So we're going to look at the coefficients right now, 15 and 45. And our goal is to find the largest number that divides into those numbers. So 15 and 45. So what I like to do in this case is look at the larger number and think about all the numbers that divide into 45. 1 times 45, 3 times 15, 5 times 9, and there's nothing between 5 and 9 that will divide into 45. So those are your factors. 1 and 45, 3 times 15, and 5 times 9. And then once you look at the factors of 45, then your job is to find the largest number in this set that will also divide into 15. Now, 1 is always going to work. We'll go to the next large number, which is 3. 3 also will divide into 15. So right now, 3 is a better choice. 5 will also go into 15. 9 will not. 15 will divide into itself. And 45 will not divide into 15. Obviously, it's too big. So you have 1, 2, 3, 4, 5, 6 factors right now, 6 factors of 45, 4 of which will divide into 15. And the largest number that divides into 45 and 15 at the same time would be 15. Okay, and you can do a lot of that part in your head if you're really quick with factors and multiplication tables, and you got those, then that process will take you less time. I was just breaking it down to show you exactly how you can think about it. Next, you're going to find the least number of times each variable appears in the problem. So you're going to look for the smallest power, and we're doing the smallest power again because we want to figure out what they have in common. So let's focus on the x's right now. We've got x to the third and we've got x to the second. This term has 3 x's multiplied together, and this one only has 2. So what they have in common, what they both share, is x to the second. 2 is smaller than 3, so you definitely want to pick that. Then we're going to take a look at our y's. We've got y to the second and y to the fifth. There are 2 multiplied to here and 5 multiplied here. Both of them have in common 2. So y to the second would be the common factor. Okay, so this, after you finish the first 2 steps in the notes, this is going to be the GCF, greatest common factor, of that problem. And so what's left to do now is to figure out what can I put in these parentheses behind the GCF so that when I check it and distribute this times this, this times this, it'll give me this problem back. So that's why a second ago I said this was the answer. Your goal was to come up with the problem that will create that answer. Since there are 2 terms in the problem, you know, it's kind of logical here, that you're going to have to put 2 terms here. Also, just look at the sign. If it's minus, you can just drop that down. And here's how you think about it. 15 times something is 15. You'll put that there. X squared times something is x to the third. We're still in the first term right now, so x squared times x is x to the third. Remember, you add powers when you multiply. Y to the second times something is y to the second. Well, if I have the same term here, or the same piece of the term here as here, I don't need another y. If I put another y there, that's going to create y to the third, and that's going to be too many. So 1x is the only piece I need for that first position of the parentheses. And you can always double check this quickly. 15 times 1, 15. X squared times x is x to the third, y to the second. Moving to the next blank, 15 times something is negative 45. We already have the minus sign there, so it should just be 3. X squared times something is x squared. Well, if you have outside what you need, I need an x squared and I have one, I don't need another one. If you have what you need, you don't need another one. On the outside, I have y to the second, but I need y to the fifth. And so that means I need 3 more y's, so y to the third. And again, you can check this piece, distribute this term times this term, and make sure it gives you that back. All the checks you should be able to do, most of them, in your head. And so for the first problem, this is the correct factorization of that. And just kind of highlighting the things I said or clarifying what I said earlier. In the last unit, I would give you a problem like this, a monomial times a binomial, and ask you to distribute it and find the answer. And this was the answer. And in the factoring part of this unit, we're going to go backwards. I'm giving you the answer. You're creating the problem that matches it. Okay, and there is only one answer for each of these, and you're supposed to be giving me the best GCF answer. So you have to go directly by these steps every single time. Okay, let's take a look at number 2. Let's start with the numbers first. We're looking at 40, 10, and 30. Again, we're looking for the largest number that divides into all the numbers. The biggest number that will divide into 10, 30, and 40 at the same time is 10. Then you're going to look at let's go with the A's next. In the first monomial, which is here, there are 2 A's being multiplied together. This term has a to the first, and this term has a to the, let's make that a 3. A to the third. We've got 2, 1, and 3. We are looking for the smallest power on each variable because we want to know what they have in common, and that would just be a to the first. Moving along, let's go to the B's. I have 4 here, 2 here, and 5 here. What they have in common is all of them have at least B to the second. Some of them have more, but that's what they have in common. Next, we're going to go with the C's, C to the third, C to the third, and C to the first. What they have in common is C to the first. Again, that is, after you go through those 2 steps, that's your GCF. It will always be written outside the parentheses, and then you'll draw yourself a set of parentheses. Since there's 3 terms in the problem, leave you plenty of room because you're going to need 3 terms. You can go ahead and fill in your signs. We'll drop the plus sign down here and the minus sign down here. And now we're trying to do distributive property backwards. So we're going to say 10 times something is 40. 10 times 4 is 40. A times something is a to the second. I have 1a on the outside, but I need 2. So I need 1 more. I have b to the second here, but I need 4. So I need b to the second. I need 2 more. And looks like my GCF has c to the first, but I need 3 of them in the first term. So we're going to put c to the second there. And again, take a second, multiply this times this in your head. Make sure it matches the first term. Next, 10 times something is 10. that would be 1. A times something is A. I have the same amount I need for the A's, so I do not need another one. B the second's what I have. I need B the second. I do not need another one. C is what I have right now. I'm supposed to get C to the third, so I need C to the second on the inside. Again, adding powers when you multiply. Last term, 10 times something is negative 30. That would be negative 3. A times something is A. I have what I need. I do not need another. B the second, I need B the fifth though, so I need 3 more. I've got C here and I need a C, so I don't need another. And so that should be the final factorization. That would be your answer to that problem. Again, this is called the GCF method. Okay, let's take a look at example 3. Looking at the coefficients, I have a 1, a negative 1, and a 1. The biggest number that divides into all of those, obviously, is 1. Then I'm going to go with my x's, looking for what they have in common. First term has 6, second term has 4 of them, and the third term only has 1. So all of them have at least 1, so x to the first. You don't have to write the 1 there. And then we're going to go to the y's. We have y to the second, y to the third, and y to the first. All of them have at least y to the first. And then I noticed the last term actually has a z to the third, but the first term and the second term do not. So because all 3 terms do not have a z, we do not put it outside in the common factor. If you put it here, you're telling me every single term has those letters. Alright, likewise, there are 3 terms right now. All 3 of these are monomials. I'm trying to find the right factors. I need 3 terms in the inside of parentheses, and I need a minus sign here. Just follow the signs, and a plus sign here. And now we use distributive property backwards. 1 times 1 is 1. X times something is x to the 6th. I have 1 on the outside. I need a total of 6 though. This is what I have to have. I need 5 more. I have y the first on the outside, but I need y the second, so I'll need another y. 1 times negative 1 is negative 1. X to the first times x to the third would get me the 4 that I need. Y to the first times y to the second would get me to y to the third. Pay attention to your powers. And the last term, 1 times 1 is 1. X times, I don't need another x, so I can leave that out. I have y the first and I need y the first, so I don't need another. And then this one had that z that has to be included in the parentheses, so make sure it's z to the third. Okay, so that would be your best factorization for that problem. Again, please don't forget to take a second and show the check, like in your head, not show the check, but you can do it in your head. Now, if you want to show it on paper, that's fine with me too. To play it safe, make sure you're getting them right. But if you do exactly what I'm sharing with you right now, you should be in good shape. Okay. All right, next let's go on to the second method called difference of squares, and then after this one we'll stop for the video today. But we're working with difference of squares problems, and because of the nature of the title, we want to make sure that we understand what this means. There's going to be a minus, that's difference, minus sign in between the terms. Remember back to the table. GCF can have any number of terms. A DOS problem has to have 2 though. And so every time you have a DOS question, guaranteed there's going to be 2 terms in the problem. There will be a difference or minus sign in the middle, and it'll be filled with squares. And by squares, I'm not talking geometry squares, I'm talking perfect squares. Okay, so I'm talking numbers like 1 times 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 5 squared. I'm talking about a power of 2 instead of the square geometric figure. And so these types of numbers are the ones that you really want to make sure you're paying attention to. 8 times 8, 9 times 9, 10 times 10, and etc. It keeps going forever. Okay, so look for the perfect squared numbers in your problems. Alright, you're going to look for two terms. Like I said a second ago, it has to have a minus sign on one of them. Usually it's in the middle, but sometimes they turn the problem backwards to see if you're paying attention. Both terms are perfect squares, so powers of 2 on the variables possibly, or most of the time you'll see that. And then look for these numbers. Here are the steps for factoring DOS. Number 1, look for a GCF first. Always look for a greatest common factor first. That's the reason I started with that method today. Number 2, find the same factors of each term. Same factors of each term. So if they give me an 81, then I'm going to use 9 times 9 in my answer. Same number. If they give me 36, I'm going to use 6 times 6 in my answer. You're going to factor these two problems into two binomials. So you're going to factor problems into two binomials with two parentheses. You're going to use one plus sign and one minus sign in your answer every single time. And you're going to then check your answer with FOIL. And on these, I would definitely check either in my head or on paper to make sure I get the same problem back. Okay? Alright, so again, on the perfect squares, we're thinking numbers like 1, 4. Let me do this a different way. Try this again. 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. And I would make sure definitely in my notes that I highlighted this section and started memorizing these because they're going to be used a ton in these problems. Okay. Alright, so I'll do it again. There we go. So on my first example over here, I have 4x to the second minus y squared. I want you to notice that there obviously are two terms in the problem. Also notice that there's powers of 2 on the variables, and so that makes sense because these are supposed to be squares. Also look at the numbers. I have a 4 and I have a 1 right here. Well, 1 and 4 are both over here in this list. So that is a classic example of a DOS problem. The first thing you do is look for a GCF. Is there a number that goes into 1 and 4 other than 1? Well, no, 1's the biggest. Do they both have an X in common? No. Do they both have a Y in common? No. So those types of questions are what you're going to have to ask yourself to figure out if it's a GCF. If it's not a GCF, you move to step 2. You're going to look for the same factors of each term. 2 and 3 kind of go together, so you're going to factor them into two binomials. So I want you to write down 2 parentheses, kind of draw 2 parentheses. And again, you're going to look for the same factors of 4. Well, that's why 4 is a perfect square, because 2 times 2 is 4, the same number. So you're going to put 2 here, 2 here. You also need the same factors of x squared. It's going to be x and x. You need factors of 1, 1 and 1. factors of y squared, y, and y. You're going to use one plus sign and one minus sign in your answer, and that is always in DOS. Okay, that's something you need to commit to memory and just do it. And I'll explain why in a second, but I've completed steps 1 through 4, so that's just kind of showing me before I check this that this has to be the answer. That's the best factorization for that problem. Now, here is why it works. I'm going to check first. Let's do a quick check. Again, the checks you can do on paper or in your head, but I need you to make sure you pick one of those and actually do it. If you skip the check and you miss the problem, that's on you. 2x times 2x is 4, x to the second. Outside, 2x times a negative 1y, 2 times negative 1 is negative 2. X times y is xy. Inside, 1y times 2x is 2yx, but I like to put the letters in alphabetical order, so you can do the same thing. And then last will be this term times this term, positive times negative is negative, 1 times 1 is 1, y times y is y squared. Now, the reason that we get to use 1 plus and 1 minus sign in every DOS problem is for this reason. These in the middle are always going to match if you do that. They're always going to be opposite signs, so when they match, we're supposed to combine them. But negative 2 plus 2 is 0, so that's good. It's gone, and that's a really good thing because I don't have an xy term up in the problem. And so if I cancel those out, I'm left with 4x to the second minus 1y squared, and check out the problem. That's exactly what I started with. So that's how I know that this part right here is the correct answer. All right, let's move to number 2. We got to classify first. To see if it's a DOS, do you see 2 terms? Check. Minus sign in the middle? Check. Power of 2 or 4, 6, 8, something that you can split up into equal same factors? Yes. 9 and 81. Well, 9 and 81 are both in this list, so we're good to go. Again, those questions you have to ask on your own. Let's look at the steps though. Step 1 is super important. We have to look for a GCF. Sometimes they don't have them, as in example 1. But look at example 2. Actually, this one does have a GCF. If I forget that, I'll get an answer, but it won't be the best answer. So please check for the GCF. We're looking for the number that goes into 9 and 81, the biggest number, and that would be 9. Both of these do not have an A, so it's not in common. So we'll just pull the 9 out as the GCF. We're going to say, like we did on the last method, 9 times something is 9a squared. It's going to be a to the second. Drop your minus down. And then fill in the blank here. 9 times something is 81, and that's going to be 9. Okay, so this one did have a GCF. The GCF of 9 will stay in the answer in every single step you show here on out. Now your focus is inside parentheses. Okay, so factors of a to the second would be a times a. Remember, we're doing a DOS right now, so 1 plus 1 minus. And then you need factors of 9 that are the same factors, remember, from your notes. And that's going to be 3 times 3, so we'll put a 3 here and a 3 here. And so that, including the 9, everything I'm highlighting is the final answer for that factorization. Okay, so today we looked at how we do GCF factoring method, how we do a DOS, and your assignment will be based on both parts. Just be careful. Please make sure that you're following your notes and your examples exactly as I've shared with you.